All right, so I went through yesterday binomial probability experiment. Okay, so just as a reminder, you got 4 rules for the binomial experiment. Number 1, only 2 possible outcomes. Number 2, trials are independent. Number 3, it's repeated a fixed number of times. And number 4, the probability of success is the same for each trial. So yesterday we went through the example of 7% of people had blood, O negative blood. You take 4 people. Now the problem is, what if you get more than 4 people? Okay, this can get really complicated really quickly. So, so the probability that x equals x, capital X equals lowercase x, okay, x equals 3, x equals 4, whatever. As you guys noticed, the order doesn't really matter, right? Okay, so this becomes a combination of n choose x, p to the x, q to the n minus x. Okay? So, I might have even done a thing here yesterday.
Is that supposed to be a big X and a little x?
A big X and a little x, yes. So here, I'll make that a bigger X. Big X and a little x. Okay? So let's just do an example here. Oh, I thought my thing was going to stay focused, and today it's out of focus. All right. Let's go ahead and open up Excel. And I'm going to share here. Okay, so let's say, turn this here, that according to Media Mark research, 86% of all U.S. households have, sure, cable, have a cell phone. I was thinking it was going to say cable TV. I was going to say, I think the numbers have gone down. All right. So let's ask the question in a random sample of size 20. What is the probability that exactly 15 own a cell phone? Okay. Now, we'll see why writing out a sample space on this. In fact, I should ask that. For extra credit, 100% on the quiz tomorrow, write out the sample size for what we just said. Who's with me? Who wants to do that? I don't think you'd have enough time if you wrote every day. If you started now by tomorrow, I don't think you'd have enough time to write out the sample size, or the sample space, I mean. All right, and so what we can do is we can use this wonderful formula here to find this out very quickly, okay? So the formula, so maybe we should go through here. What's my n, and what's my x? What's my p? What's my q? Okay? We'll do that really quickly, and then we can just plug it in, right? So my n in this case is 20. My x, 15. My p, 0.86. My q, 1 minus 0.86, which is 0.14. Okay? So I've got everything I need to know to plug it into this formula now. Okay? So you guys all remember how to do combinations, right, with Excel? Okay? Yes, no?
No, not really.
No, not really? Who remembers? Equals combin. Thank you, Eric. Combin, the number is 20, and the number chosen, 15. We're now going to answer the question, how big is your sample space? A mere 15,504. That's worth 5 points on the quiz tomorrow, right? Okay. Make sure you don't write anything twice. Yeah, there's 15,000 ways you can get 15 out of 20. Okay. Successes and failures. That's kind of large. Okay, so now I need P to the X. P is 0.86 raised to what power? The 15th power. And then I need Q to the N minus X. Okay, what's Q again? I can click on it too. Q is 0.14 raised to the, and I'm going to use parentheses on here. N is 20 minus X is 15. I could have put a 5 there if I wanted to, but yeah, so as I write this on the board, maybe I should do this really quickly on the board. I'm trying to edit over here so it's kind of on the video. So I've got a combination of 20 choose 15, 0.86 to the 15th, 0.14 to the 5th. Okay. Notice these two numbers, if you add them up together, add up to your N. Okay, does that make sense? Okay. Now I've just got to multiply those three things together. And so if I get the probability of X, the probability that X equals, in this case, 15, I multiply at that times that times that. Probability that you get exactly 15 out of 20 would be about 8%, 8.6%.
Real quick, so we just sum.
Multiply. Multiply, not a sum. It's multiply. Okay? All right. So I think I talked about different things in my two classes yesterday. Did I show you guys how to do do you think Excel could do this even faster than that?
Yeah.
Okay. Are you going to be able to do this on your quiz tomorrow? No. So you need to know this way. Tomorrow is going to be your calculator, so you need to know this way. But yes, there is a way on the computer that you could do this. Yes.
Where did the Q come from?
Q is 1 minus P.
Oh,
Remember, I mentioned that yesterday. So yeah, Q is 1 minus P. All right. Well, I guess I still never got that. I'm barely on the video. All right. So the Excel way, okay, is to say, if you were doing something with the binomial distribution, what command would you use? Binom. Okay. Now there's two commands you can use. You got the binom.dist and the binom dist. They're exactly the same. There is no difference in them whatsoever. It doesn't matter which one you pick. But I'll pick the top one. That's the newer command. Okay. Number of successes in this case would be 15. Number of trials, 20. Probability of success, 0.86. Okay, now, before I press enter on this one, okay, now it's asking you, do you want the cumulative distribution function? We tested you on that like 2 tests ago. What is the cumulative distribution function? Who remembers? That's what I thought. Okay, this is always the hardest part because when you're doing this, sometimes you're going to answer true, sometimes you're going to answer false. You need to know what the cumulative function is in order to know whether this is true or false. Okay, and it's going to be very situational on what it's asking. So let's review very quickly. Okay. In fact, before we do that, I'm gonna save that. Well, here, I'm going to tell you the answer is false, but I want to explain why. You should get the exact same answer I just did. Okay. Sometimes you are going to want to press true. And in fact, I think this is a good test, good case where I want to create a histogram of this data. Okay. Now, This is going to be a long answer. We got more time today because I started yesterday. How would you create a histogram for this probability density function? What'd you say?
Never mind. Not sure.
Never mind, not sure. Anybody know? Okay, is this discrete or continuous? It is discrete, right? Okay. And normally when you're creating histograms, you would group them. When they're discrete, they're kind of grouped in a way. So I'm not going to worry about grouping them. Okay. So what's my sample space if I'm interviewing 20 people if they have a cell phone? What's my sample space? Okay, so that's for 15. But what are all the so if I talk to 20 people and I say, do you have a cell phone? Out of 20 people, how many people could I get? What are all of the possibilities? I could get 20. I could get 0 to 20. Okay. All right. So my sample space. So I'm going to put my x here. My x is going to be 0, 1, 2, all the way down here. And we're going to go down to 20. 20 is right there. Okay. Now I need now I need to find the probability. Okay. Now, honestly, you guys really need a lot more practice with this. Tell you what, we're going to do it this way. We're going to give you guys practice. Okay, so I'm going to do the combinations, and I'm going to do the p to the x, and I'm going to do the q to the n minus x. Okay, because you guys need practice. Otherwise, I would use the binomial dist. But actually, I'm going to show you. I'm still answering that question about cumulative distribution. Okay, so combination, this is going to be a combination of, what's the number in this case? It's going to be 0. So I'm going to actually click on the 0 so I don't have to change this every single time. Comma, how many are chosen? 20. My n is 20, right? Okay. Oh, what did I do?
Get the F4.
Number error. Does it not do that one? That should have worked. Combination. Did I do it backwards? Equals combination.
Just because it's a 0.
Oh, that should have worked. Oh, sorry, I did do it backwards. It's 20 comma and then this number. I did it backwards. Okay, that's why it erred on me. Okay, now it worked. Because remember, let's talk about that for a second. I'm doing a combination of 20 choose 0, which if I were to write that out would be we just learned that 2 days ago. Yeah, 20 factorial over 0 factorial 20 factorial. Okay, those two cancel. What's 0 factorial?
1.
1, because we said so. And you get 1 over 1, which is 1. Okay? All right. Now I'm going to copy that down for all of those. Okay? Now I'm going to do the probability of x. So the probability is going to be the p 0.86 raised to, and I'm going to click on this so that I can copy that down. Okay?
Raised to the sample space or
To the x, your x column. Okay? Now I'm going to do q, which is 0.14 raised to the, and I really should use parentheses here. My n is 20 minus my x. Okay? That's a very small number. I'm going to copy that down. And now I'm going to do, tell you what, I'm going to end, well, probability of x. The x equals, here, I'll write it this way, x equals x. Okay, the probability that x equals 0 people is going to be the product of these 3 numbers here, which is really puny. So if 86% of people had a cell phone, the probability that you got 0 people is like ridiculously small. Okay? All right, so now I'm going to copy that down. Okay. All right, so now my question is, we want to make a histogram here. Who remembers? So we've got all the information we need to make a histogram. So I need my X column, and I need the last column. How do I get the last column? Hold the control key down, and then I'm going to just take this last column here. Okay. Now I can make a probability histogram, insert, scatter, or not scatter plot, 2D column. Oh, why didn't it work? You notice there's a little bit of red in there? Why didn't it work? Because why?
Apostrophe.
I need the apostrophe here. Okay, I should have done that at the beginning. Apostrophe there, apostrophe there. We're going to change this to a text. We're going to double click. The nice thing is Excel's smart enough to know, even though that's a text, I'm still going to treat it as a number, which is really kind of a cool feature. Do this again. Highlight that. Hit the control key, highlight this. Insert, scatter, 2D column, or not, I said scatter, but I meant bar. Quick layout, change it to there, look at that. Doesn't that look like a nice histogram? Okay, we're gonna label this, this is what? What does this represent? Anybody know?
The number of households.
Number of households with a cell phone. What does this represent? Probability. And what should I put here? Probability histogram out of 20 households. Okay. Now, does that look like normal distribution to you? Kind of. It's a little bit skewed. Which way is it skewed? Skewed left. Okay.
Good question. Could you do that again? Sorry, I missed the spot where you went from the data to the histogram.
So you turned all these, you put apostrophe in front of all your X's, right? And then I'm going to take column A and column E in this case. Okay. Now, just for fun here, I did that one by itself. So this is the probability that X equals 15, and I got 0.086. X equals 15, I got 0.086 again. See that? Okay. X equals 15, that's going to be this column right here. Okay. Which is just below 10%. Okay. So that's exactly 15. Okay. So this is what we would call our relative frequency, right? What is relative frequency again? I'm going to test you guys on this again. You've already forgotten this one on the first test.
No.
Don't remember it at all? Okay. This is all this is to get ready to answer what's the cumulative frequency. Relative frequency is your percent. Okay. What's the cumulative relative frequency? Remember that? Remember how to find it?
You have
All the relative frequencies up. So everything below 0 is that number again, right? Everything this plus that. Remember that now? So we've got 1 times 10 to the minus 15th that are 1 or 0, okay? What should this add up to at the bottom, if I did it right? 100%, okay? All right, so now what we can see here, if X equals exactly 15, that's going to happen about 8.5% of the time. What's X 15 or less? It's staring you right in the face.
13%.
It's 13.7%. Okay. So so if I wanted 15 or less, I'm just adding up everything above this, right? And that adds up to 13.7%. Okay. So going back to this, okay, this is Excel where X equals 15. It's 8.6%. What if I wanted X less than or equal to 15? Okay, this function, Binomial will do that for me. What's the number of successes? $15. Number of trials? 20. Probability of success? 0.86. And if it says less than or equal to 15, do I want the cumulative this time? True. Okay, and that should be a 13.7%, and it is. Okay? So, isn't that a nice little function?
You can use that on test.
You can use that on the computer test, but you have to do all this stuff if you're doing, now that would be a horrible mean problem to do on the quiz tomorrow, on the paper tomorrow. But you know, I could do 2 wouldn't be bad. Okay, you could figure out 0, 1, and 2 by hand and then add them all together, right? Okay, yes.
Can you show how the relative frequency adds up to 100?
Can I show what?
How it adds up to 100?
Oh yeah, I never went to the bottom, but I 100% right there. Okay, bottom one is 100%. Okay, and by the way, hopefully this column adds up to 100% too. And it does. Okay. All right, so I know this is the tricky one. And this is the one command where usually I'll be like, it's almost always false. But this is the one where it's like, you got to know what you're doing. Sometimes it's true, sometimes it's false. Okay. So let me ask you another question. What if I asked you, what's the find the probability that at least 18 own a cell phone? Now the nice thing is, because I did that histogram, this is really super easy. If I was asking you this fresh, you'd have to do a lot of calculations, but I've already done those calculations for you. So how would you find the probability that at least 18 own a cell phone? 18 and above, at least 18. So this would be, in this case, what? Because it's actually staring you in the face. What's the probability that I get exactly 18? .79? No, that's incorrect.
0.24.
0.246, right? That's 18. At least 18 would include 19 and 20. So I'm going to add 0.159 and 0.048. Okay? Probability that at least 18 did that. Now, what if you didn't have that information? I'm going to leave it there. But what if you didn't know that? How would you do this problem? You'd have to figure, so 2 answers to that. You'd have to figure these out yourself. Sorry, 1, 2, 3. You'd have to do 18, 19, and 20. If you're using your calculator, you're just going to have to figure it out. You're going to have to use this formula right here to figure it out. Okay. Then, or if you're using Excel, there's a super duper easy way to do this. And that would be with the cumulative distribution function. Okay. So let's think about this for a minute. Yeah, this should be on the word. Probability that X is greater than or equal to 18. Now the cumulative distribution function tells you everything above it. It doesn't tell you what's beyond it, right? How could I do this with the cumulative distribution function? Remember, when I say at least, and I don't want to do a bunch of calculations, which other way?
Do 1 minus.
Very good. The complement rule. 1 minus probability that, this is where I want to be super, make sure you're super clear on this,
Less than 17.
x is less than or equal to 17. Okay? Now, so that's the complement rule. Now, if I'm using Excel, I don't need to do 17 calculations, or this one only is 3, which isn't bad. But I can actually, Excel will do this. So I can get the exact same answer equals 1 minus what? What's the cumulative distribution function? Binomial dist. Binomial dist. And just to show you, I can use the one without the periods. I'm going to use that one. They're exactly the same. There is no difference in them. Okay. Number of successes in this case is 17. That's the one trick. 17. Number of trials, 20. Probability of success, 0.86. P is still P. Remember? 0.86. Okay. And do I want cumulative?
Yes.
Yes. This time I want to put true. Okay. Hopefully I get 0.455019. Booyah. Okay. So you need to know when to say true and when to say false. Okay. Let's see how good you are. Find the probability that the cell phone use numbers is between 15 and 17 inclusive. Okay.
15 to 17.
15 to 17. How would you do that? A couple different ways.
Cumulative, let's see, for 17 minus 15 or minus 14.
Oh, very good. So he did it with the, okay. So very good. I'm not going to say yours yet, but you're right. Okay. We'll do that one in just a minute. But since I've got my table here, I could just go 15, which is this, plus 16 plus 17, right? That's the easy way to do it. If you have a table, if you don't have a table, you use this and you create it for those three. That wouldn't be that bad, right? That would work out to be 0.494, or as Tyler said, okay, you could say, so let's think about this again. Once again, I'm going to write this on the board. Probability that x is between 15 and 17. Okay? So if we're doing the cumulative distribution function, we're going to do the probability that x is less than or equal to, let's do this side first, that's the easy one, 17, right? And we're going to subtract off the probability that x is less than or equal to,
Greater than or equal to.
no, we're leaving it as less than or equal to because we want to use the cumulative distribution function. So is this 15 or 14? It's 14 because we want to include 15. And if I put a 15 here, it doesn't include 15. Okay? So if we take those two probabilities, we can use the cumulative distribution function if we're using Excel. Now, obviously, this is a great test strategy. It's going to be a horrible quiz strategy. The quiz strategy is what I just showed you. You're going to have to figure out, you're going to have to use this equation 3 times, one for 15, one for 16, one for 17, and do it just as we said. Okay? So that's what you really need to know for tomorrow's quiz, but if you're doing it for the test, this is going to be the super easy way to do it. Okay? So I'm going to do binomial dist. Number of successes is 17. Number of trials is 20. Probability of success, 0.86. Do I want true or false?
Can you do what you want to do?
What? If I'm doing it cumulative, I want true. I could do this with false also. I'll show you that in just a second. See, there's lots of ways to do this. And then I'm going to subtract. I'm just going to copy that same thing. I don't have to keep typing it. But now I don't want that 17, I want that to be a 14. Now hopefully I get 0.494. Okay? How about it? Okay? So you need to study with Tyler, he knows what he's doing. Okay? Now, if I wanted to do this with the faults, I could do this. Basically, I'm going to do the probability that x equals 15, probability that x equals 16, whatever, stupid thing. And probability that x equals 17, okay, equals binom dist, number of successes, 15, 20, 0.86, and this time I'm going to say false, okay. Oh, I need a comma there, not a period. Okay, I'm going to copy that here and here, and I'm going to change that 15 to a 16 and a 17. And when I add those three up, I should get 0.494. How about it? Okay? Confused yet? Okay? So yeah, that's pretty cool. Now let me ask you a question. After all that probably, it's a good thing we started this yesterday, huh? The other class I didn't start it, so we're going to be booking. Let me ask this question here. What is the mean of binomial distribution? Before I answer that question, I want you to just think about this logically, okay? If 86% of people own a cell phone and you talk to 20, what would you expect to get? 86% of 20, right? The mean of a binomial distribution is simply n times p, okay? If your n is 20 and your p is 0.86, you just multiply those together, that's your mean. So that's a super easy formula. Like that even makes sense, right? So the mean equals 20 times 0.86. So you would expect 17.2 people out of 20. Now, is it okay that I've got the 0.2? Yes. Okay. You'd probably, in real life, you'd expect 17, but you get, you'd get more than that sometimes. So yeah, don't chop that off. 17.2 is your mean. Okay. Now the standard deviation isn't going to be quite so easy. The standard deviation of binomial distribution. Okay. This is standard deviation formula number 4. Good thing I'm giving you a formula sheet, right? Now you just got to know which one it is. Okay. This is the square root of npq. That one's not quite as obvious, but I can do that. Standard deviation equals the square root of n, which in this case is 20 times 0.86 times 0.14. Okay, 1.55. Okay, so, and it kind of makes sense. Now that I've got my histogram drawn here, you would expect if I were to draw a line here, let me draw a line, insert a line 17, so you'd expect it to be about right there. I can draw my thing here, and you'd say that the mean, and that makes sense, right? That's about where you'd expect your mean to be, right in the middle. Text box, and I would say my mu equals 17.2. Okay, does that make sense? Well, I thought we were going to cover more there. Okay, what if I did, let's just ask one more question and I'll let you go. It's a good thing we started this yesterday. Out of 300 households, we'll still assume the same thing. Find the mean and the standard deviation. So what do you think, Jacob?
Your sample size is going to be, that'd just be 300 times by 0.86.
0.86. So you would expect about 258 people. And your standard deviation would be square root of 300 times 0.86 times 0.14. That's actually a nice, easy, that's one of the easiest standard deviation formulas to remember, right? Okay. 6.6 roughly. Okay. All right, and then I'll let you guys go, but you know what would be a fun practice? Do that, make a histogram for 300. And then tell me tomorrow what it looks like. Now you don't want to do that by hand, that would suck. But by the computer, we can split it. Okay? What's that? Extra credit if you do it by hand tomorrow. And especially write out 300. I'll let you do 300 and 150.
Always drop the class.
I want you to list out that second. Let me stop this.